So last time we talked about the organic farming as ecosystem management, and this is a good example of that. The way that you're going to be feeding your crops is by introducing nutrients into the soil in a way that's in tune with natural systems, where nutrients are going to be released gradually as they're broken down, as opposed to putting an input with nutrients on that's man-made or chemically manufactured. So what is soil organic matter? Soil organic matter, soil is made up of a huge different number of things. 5% of what soil organic matter is, of what soil is soil organic matter. And soil organic matter I'm introducing now because it's going to be referenced a lot through this slideshow. And I will be abbreviating it as SOM so that I don't have to write soil organic matter every time. So this is 5% of what makes up soil, and it's the only living part of soil, or the only part of soil that is or was living. So within that 5%, you've got about 5% living organisms or microbes, about 10% of stuff that's freshly dead. 33 to 50% is stuff that's actively decomposing and being eaten and excreted by the living 5%. And then the remaining 33 to 50% is humus. Humus is highly decomposed organic matter that's also in a very stable state. So it's not really actively undergoing more decomposition. It can be stable for thousands of years, which is pretty mind-blowing. And this is what acts as glue in soil and what is really key to soil structure, which is something that we're going to talk more about later on. This is the stuff that's basically been digested to the point where it's too hard for microbes to digest it further. And so having all of these components in your soil is very important in organic farming. And a lot of what we're going to talk about today is how to build soil organic matter and maintain soil organic matter. So what is the role of soil on our organic farm? And then we will go into some of these points in more detail. So decomposition, mineralization, storing nutrients, breaking down pollutants before they get to surface or groundwater. And, that's a key thing that's become an issue with chemical fertilizers, is that they can be easily leached, run off of the land because there's usually more than what the crops need. And that's what, causes ecosystem problems elsewhere, especially in water, like in the Gulf of Mexico, where there's a big dead zone. A lot of that is caused by things like chemical fertilizer runoff. Soil on an organic farm is also important because it stores huge amounts of carbon in a very stable form. So this is beneficial not just for the farm itself, but for the whole world, because it's sequestering carbon, keeping it out of the atmosphere, helping with global warming. Number 6, nitrogen cycling, which we will go into, disease suppression, and water retention and absorption. So now we're going to dive into each of those. So number 1 and 2 are decomposition and mineralization. And these are the two things that I immediately think of when I think of the role of soil on an organic farm. So soil microbes, so all those little bacteria and fungi that are in the soil, and then you also obviously have larger organisms like earthworms and other little insects. But soil microbes and other organisms will break down dead matter. So they will then use the nutrients that they need to keep their cells functioning, and any excess nutrients will be released back into the soil. And this is how you are providing nutrients to the crop. So any nutrients that the microbes process through and release are then become available to the crops. Nutrients that the microbes use are going to be released much more gradually than if you're putting down a fertilizer that is already that nutrient in an available form. So that's going to help several things, which we'll get into a little bit more, but it's going to prevent nutrients from being lost or leached out of the system, and just going to help the plants, have access to nutrients over a longer period of time. Bacteria are one type of soil microbe, and they're going to be kind of the first ones to come in. They're going to decompose the easier to break down stuff, which is usually sugars, while fungi are then going to come in later and break down the more complex stuff. This process is how most nutrients that plants need are made available to plants, including like big important ones like nitrogen, phosphorus, and sulfur. One of the third point that we talked about the role of soil on the organic farm is storing nutrients. And I did touch on this a little bit in the last slide. Microbes will store nutrients that are a result of the decomposition process, and they'll release them gradually, which, as I had mentioned, is a slower release over time, less leaching, more consistent availability. This means that nutrients become gradually available as decomposition happens and are able to feed plants in a much more natural way and gradually over a longer period of time. We discussed number 4 and 5, so I'm going to move on to number 6, which is nitrogen cycling, which is a job of bacteria in the soil. And so there's 2 types of nitrogen cycling that we'll talk about: nitrification and then nitrogen fixation. So nitrogen fixation is a process by which nitrogen is pulled from the air and put into a form that plants can use. And the forms of nitrogen that plants can use are either nitrates or ammonium. And so nitrogen fixation is this pretty amazing process that specific types of plants are able to do. And these are the legume family, which includes not just things we eat like peas, beans, and things like that, but also some of the cover crops, which is something we're going to talk about later, like vetch and clover. And what happens, it's a symbiotic process where bacteria called rhizobium, they build a little structure. And I actually am realizing I wish I had gotten a picture of this, because I've actually pulled up plants and you can see these structures. They build a little structure for themselves on the roots of leguminous plants. And this is where within these little structures, it's like you'll have the roots, and then on the roots, there'll be these little pinkish looking, like bulges on the roots, and that's where the rhizobium are. And within these structures, they carry out nitrogen fixation. The plant provides the bacteria with sugar, and then the bacteria provides the plant back with the nitrogen in the form that it needs. And rhizobium bacteria are not going to be present in every soil. So most farmers are going to inoculate the soil over time to introduce these bacteria. We use a product, we've used a few different products over the years. The one that's currently available, and we get it from Johnny's Seeds, is called Exceed Garden Combination Inoculant. And what you do is when you're going to plant, you can either wet the seeds a little bit and mix in the appropriate amount of the inoculant, and it's just a little black powder, or you can mix it in dry. And so therefore you're putting the seed in the ground at the same time that you're putting the rhizobium in the ground, so that as the plant grows, the rhizobium will be available. And at this point, we've planted legumes in most places on the farm. And so I can go out there and pull up, clover from a pathway that was not inoculated, and that will also still have the rhizobium on it. So then that is the one form of nitrogen cycling that the soil is very, very essential for, soil microbes. Another form is nitrification. And this is when bacteria change ammonium, that's a byproduct of mineralization. Mineralization is the bacteria breaking, or the microbes breaking down the decaying material. So bacteria can actually change nitrogen that comes out of the mineralization product as ammonium into nitrate. And so nitrate, you may have heard it used in combination with chemical fertilizer. But this is actually a way that you can provide nitrate to your crops in a completely natural way, in line with natural systems, and where it's released much more gradually without the same concerns of leaching. And then another very important part of soil in organic farming is disease suppression. And you'll see a similar thing come up when we talk about pest and disease control above the ground. But, obviously below the ground, you're going to be competing with pests and diseases as well. There's, a variety of diseases that either happen below the soil surface and attack plant roots, or that happen on the soil surface. And, especially fungal, these are usually fungal diseases on the soil surface and below the soil surface. So, the soil organic matter, it's alive. It's got these active microbes and organisms in there. So several things that the beneficial microbes can do. They can actually attack and eat problematic pathogens. Another thing that I find this process very interesting is that they can simply outcompete them. Like if you take a bit of soil, and the example I have here is if that bit of soil has the space and food for 10 microbes, the more positive microbes, beneficial microbes you put in that area, and by creating ideal conditions for them, the more space that's taken up by good microbes, that means the less space that's going to be available for pathogens. So an example of when we have done this is and this has actually been for a pest control issue, but I believe these also can be effective for disease control. We started a few years ago having issues with something called the onion root maggot, which will, it can completely destroy your onion, garlic, any of those kind of crops. And so we started using nematodes, which are a tiny little microbes that we would, water into the soil with a watering can. And you can get a few different types of nematodes depending on what problem you're trying to solve. They have kind of funny names. That one is called Nematac, and the other one I think is Nemaseek. And one of them just kind of hangs out in the soil and like waits for things to come to it. The other one like actively goes after pathogens. But these, help in both of these things I talk about. They can both outcompete problematic other things in the soil or actually attack and destroy other things in the soil. Another type of microbe in the soil, there's lots of fungal microbes that are not just bad ones. There's tons of good ones, including one that's called mycorrhizae that does kind of provide a shield over plant roots. And I believe there's actually things which I've never used that you can water onto transplants to kind of like inoculate that soil with these to help provide a shield against some of these disease pathogens in the soil. And then the final point, number 8, was water retention and absorption. So the term field capacity, that means how much water a field or the soil in a field can hold before the water drains through the soil or runs off of the field. And, this is obviously going to be affected by things like how wet it is, how dry it is. In 2017, when we had a record year of rainfall and we were getting way more rain than the soil could hold on to, and also we were getting extreme amounts of rain at a time, we, were experiencing a lot more runoff than we do in a standard year. And I had mentioned this last time, we ended up building drainage ditches to try to mitigate the effects on the actual field. So soil aggregation is the size of the pieces of soil, and that really helps determine what amount of water can get in. The bigger the soil pieces, the more water can get in. And your goal is good aggregation, but you want it's this very fine line. So you want smaller aggregates so that the water will hold on to the soil but not be oversaturated. So there's several types of soil. There's clay soil, which is going to have big aggregates. It's going to hold more water, and it's much more likely to get overly wet. Then you can have sandy soil, which, as we all know, sand has very small aggregates. If you try to squeeze clay together, it's going to stick. If you try to squeeze sand together, it's just going to fall through your fingers. Water runs through sandy soil. I have never farmed on sandy soil. It seems like it would be very challenging because water runs through it very quickly. It's more likely to dry out and have erosion and runoff issues. Loam is kind of the ideal soil, and like obviously not everybody's going to be able to have ideal soil all the time. To some degree, you have to work with what you get, and people work with all of these types of soil. But loam has kind of the ideal aggregate size where it's able to take in and hold on to water, but not too much water. So, I mean, you can see that ideal for farming is 25 to 35% soil aggregation. You'd probably need to get a soil scientist to come out and tell you exactly what percentage you have. I'm hoping we'll have time at the end to look through these 2 resources. One of them is just 2 methods to test for your soil texture, both of which I've done, and I just found a website that goes through the process very well. And then this other website is a USDA website. It's called Web Soil Survey, and it's an incredibly helpful resource where you can find for either the property you own. If you're looking for a property, you can find exactly what type of soil you have, so that like when we were looking, somebody recommended this to us when we were looking for farmland, because you want to have the right type of soil. If you're choosing, you would rather choose a loam over a clay or a sand. You want to choose something that's deep enough. And so I will try to make sure that there's time for us to look through those websites quickly for a little more in-depth info about soil. All right, so how do you build soil organic matter? Because number one, you can't just rely on it being there from the get-go. We test our soil about every 3 years, more often if we notice issues. So the first thing we did before we started the farm is we did a soil test. So we had a baseline for not just nutrients, but you can also have it tested for like organic matter levels. And so we did that test, and then we continue to monitor it, because the goal with organic farming, and this is something like when we talked about the NOP guidelines and standards that you have to follow as an organic farmer, this is something you have to be able to say that you do. You have to prove that you can do, is either maintain or improve soil organic matter. So this is a huge part of the forms that we will talk about in a later webinar that you have to fill out every year as an organic farmer, is showing that you do most of the things on this list. So we will go through these one at a time and talk about what they mean and how we carry them out on our farm. So here we go. First, we're going to talk about cover crops. So cover crops are non-crop plants that are grown in a field, and there's various reasons you can grow them, including building up the humus in the soil, increasing biological activity, number diversity of organisms, increasing crop diversity, which also then below the surface will increase microbial diversity. There are leguminous cover crops like vetch and clover, which can fix nitrogen, and if you incorporate them into the soil at the right time, that's going to increase the nitrogen you have in the soil. Cover crops are also one of the big reasons we use them is over winter, decreasing nutrient loss, because there tends to be a lot of precipitation in the soil. And, if soil's just sitting bare, you're going to lose nutrients, you're going to lose soil, you're going to get compaction in your soil. Deep-rooted cover crops, which, include things like rye and, but also things like radishes can loosen and aerate soil if you're struggling with compacted soil. Cover crops prevent erosion and compaction, and they're also important for weed suppression. So how do we use them on our farm? So these are some of the cover crops that we use the most on our farm. Winter rye / winter rye vetch mix. That's something that is the most common one that we use over the winter. You have to plant it early enough for it to establish, or if you plant it later, then what you want to make sure that there's enough time in that bed in the spring for it to grow and establish in the spring. So it continues to grow over the winter and into the early spring. So it's going to provide protection from rain and snow compaction over the winter, And it's also going to provide weed control, especially as you get into the spring and weeds start growing. If you already have a very thick stand of cover crop, that's going to, just like we were talking about underneath the soil with soil microbes, that's going to prevent, outcompete other weeds. Another very interesting thing about rye is that it has what's called an allelopathic effect. Allelopathy, that is when there is something in the plant that when it's tilled in, it makes it more difficult for other plants, other seeds to germinate. So that obviously also helps with weed control, because as you till it in, weeds are not going to immediately begin growing afterwards because they're going to be affected by the allelopathic nature of rye. So we also put in a mix of rye and vetch. Vetch is a legume, so that's going to help add nitrogen to the soil. One of my favorite cover crops that we have started using in recent years is buckwheat. This is one that does not grow in cold weather. It would kill in cold weather, but it grows very well and very fast in warm weather. So anytime we have, a 4+ week window between two crops, I just throw buckwheat in the ground. It grows so quickly, it's almost guaranteed to outcompete weeds. And then it has a further benefit that when it's left to flower, it attracts a huge number of pollinators, which we've found, just is really great for the overall diversity of the farm. We also use an oat pea mix over winter. In a normal winter, or, oat pea mix usually winter kills. So the idea is that it's going to, rather than like rye be growing in a green form all winter, it will basically create a mulch. It'll die and it'll almost look like straw is on the beds. And then it just covers those beds in the spring. It makes it a little easier to incorporate when you get to the spring, because you can, if it fully dies, you can basically rake it off the bed. It can then mulch the path, and, it allows you easier access to the beds in early spring. Clover is something that we also use in paths and in beds that are out of production for a year or more. Clover is very slow to establish, so you kind of have to be thoughtful about when you seed it, because it can get overtaken by weeds. But once it does establish, it's very thick mat. It is perfect with white clover. It's a perfect ground cover for walking on, and it is also a legume which will, add nitrogen into the soil through fixation. Green manures are the next method we're going to talk about. So a green manure really is any plant matter that's incorporated into the soil by tilling or plowing. It can include both cover crops that are tilled in, or actual crops, or even weeds. And benefits of this is that this is a perfect example of how you're feeding the soil organic matter, and just providing food for the food web in the soil. You're adding just a huge variety of food into the beds. And in a couple slides, we'll start talking about crop rotation, and we both rotate our crops and we rotate our cover crops, so that you're adding a good mix of green manures to turn into the soil, so that you're able to feed a variety of microbes and have a good diversity below the soil as well as above the soil. And then also, like I mentioned with rye, some things that you till in are going to help inhibit weed seed germination through allelopathy. You can also help build humus in your soil by turning in carbon heavy plants like corn. So on our farm, we have a pretty prescribed method for how we prep beds. So we use a BCS, not a tractor. A BCS is a tractor, but you walk with it instead of riding on it. But we have the same type of implements as you would use with a standard tractor. So we go through and mow down the beds with a flail mower, and then till in whatever crop residue is still there about 2 to 4 weeks before planting the next crop. So either that's tilling in the cover crop, or it's tilling in the crop that's there. Then we put down a tarp over this once it's tilled in, and that helps to speed up the process with which the crop material that was turned in is going to be broken down. And you want the active breakdown stage of the green manure to be finished before you plant into it, because active microbial activity can inhibit germination. This is less of an issue with if you're transplanting, already grown plants in. If you're direct seeding, it is much more necessary that you have broken stuff down. So you're looking more at the 3 to 4 week window. With transplanting, or even with potatoes, I actually have started recently with our potatoes is growing winter rye on those beds and tilling it in almost immediately before I put the potatoes in, because the potatoes will germinate fine in that, and it will then further suppress weed seeds while the potatoes seem to germinate fine. And then we'll talk a little more about tillage later, but green manure is a very important aspect of our soil management plan, because tilling the soil, which if you're familiar with implements, tilling basically stirs the soil up, whereas plowing, like certain types of plowing, it's more turning the soil over, but tilling is actually breaking the soil up. And so in order, that is going to have negative repercussions for the aggregates in the soil. It's going to break them into finer aggregates, which is less beneficial for how the soil functions. And it's also going to introduce a lot of air into the soil, which is going to speed up microbial activity. So by not just tilling soil that's bare, but tilling in green manure, that's going to help combat both of those aspects. It's going to provide the microbes with food so that they're not just, as their activity speeds up with the increase of oxygen, they're not just eating through everything and leaving nothing for the plants. It's also, by tilling in green manure, you're constantly adding organic matter back into the soil, which is going to help rebuild soil structure over the long term. So green manure, incredibly important aspect of organic farming. And then crop rotation. This is also a requirement of the National Organic Program. Crops, it means that crops in the same family should not immediately follow each other in the same bed space. The reason you want to be rotating your crops, I touched on this a little bit, but nutrient cycling, because different crops are going to have different nutrient needs. So you're going to therefore be pulling different nutrients from the soil each year so that you're not, completely depleting certain nutrients. This is also going to help with pest and disease control, because you're changing around the availability of host and habitat. You're going to increase biological diversity above and below the ground, because different crops and crop residues are going to increase, are just going to offer different food sources, both above the ground, but what we're talking about today is below the ground. So as you turn them in, or just their root structure, or the microbes they attract, for instance, with legumes and rhizobia, you're going to just increase the biological diversity, which is so important in all levels of organic farming. And it's also going to be very helpful with weed control, because different weeds compete better with different crops. Like if you think about, winter squash plants that are, spread out with big leaves, those are going to be much better at suppressing weeds than, a plant like, corn that just grows straight up. And so there's different weeds are going to do better in each of those, with each of those crop plants. So by rotating, you're going to kind of break up weed cycles and make it harder for any weed to really establish itself. So this is our crop rotation, and we are going to touch on crop rotation in more detail in, I believe, in the next webinar. But just as a quick overview, this is our crop rotation. You'll see that brassicas do follow each other more often than I would like them to. Brassicas make up a huge number of the crops in a market garden, because it just covers a bunch of different things. And so we do our best to get them as far apart as we can. And then even within the rotation, the way that our rotation works, we've got, 15 beds per section. And so we will try to rotate even within those sections. So you can see in one of the years, there's scallions, I believe, are fairly close behind garlic. And so the way that we manage that is just make sure that the scallions and the garlic are not going into the same beds in that section, so that there's not just rotation around the entire farm, but even within the bed sections. And again, we will talk more about this in the next webinar. All right, so animal manure bedding, that's another way to build soil organic matter. It adds nutrients, improves soil structure, and it's a perfect thing to do if you have animals on your farm, because you already have that resource. However, this is something that does fall under this specific regulation in the National Organic Program. It's the 90-120 day rule, which says that manure cannot be applied, or this is written wrong. Manure has to be applied. Oh no, I'm sorry. Manure cannot be applied less than 90 days before harvest of a crop that doesn't touch the soil. And if the crop does touch the soil, like say a head of lettuce, there has to be 120 days between when you applied manure and when you harvest the crop. And that has to be very well documented. That also comes into effect when we talk about compost. So compost is, I'm sure everyone is familiar with this, and it is also a very, very key part of an organic farm. We apply compost before before every single planting in our hoop house, and once a year to every single bed outside in the farm. The reason we apply it more outside or less outside is because we are also applying so much more green manure outside, whereas in the hoop house, we're all hand managed in our hoop house. So we are not using green manures, are not getting incorporated in the same way in there. So compost is defined as decomposing or breaking down dead plant and animal matters into a stable form that's no longer heating and is no longer actively decomposing. Benefits of compost are it provides nutrients to the soil microbes that then, are going to provide it to the plants. It helps, continuously inoculate your soil with these microbes. It's going to increase the soil biodiversity by just being another source of organic matter into the soil, and it's going to help build soil structure. However, compost, you have to be careful that it is considered that it is properly cured compost. And you can read here the very specific rules, because if compost doesn't fit into these guidelines, it also falls under the 90-120 day restrictions that we talked about a couple slides ago. We in the next slide, I think I talk about what we do. So on our farm, we don't actually use compost. We only use what's is referred to as leaf mulch, and there's some other names, which is decomposed plant matter that has no animal matter or waste in it, so that it does not, we can completely avoid the 90-120 day restrictions. We purchase it in bulk from local garden centers. And while we do have a compost pile on the farm, we don't actually use it on the beds, not just because of the difficulty of meeting the composting requirements unless you have a commercial facility, but also because we don't want to re-inoculate beds with weed seeds or diseases from stuff that was pulled out. But we basically use it as a sustainable way to just break down plant matter, in a natural way over time. Another way to add to your soil organic matter is both mulches or living mulches, which are pretty much the same, but two different things, because one's alive and one's not. These are both going to protect the soil and provide food for soil microbes. Non-living mulches, a perfect example would be straw. Living mulches, it's like what I was talking about, how we plant clover in our pathways. And living mulches can be great, especially over the long term, because the best way to build soil organic matter is in permanent ground cover. permanent sod has a huge root biomass and which is hugely important to building soil organic matter. So that's why we will sometimes take beds out of production and just have them covered for a few years to kind of just help build things back up. On our farm, the main non-living mulch that we use is straw. We mulch all of our garlic beds with straw at the time that they're planted. The potato beds are, I was talking about how I've kind of started experimenting with this new technique where I do rye over winter, but previously those would be in straw mulch over winter to help protect them and still provide food for the microbes while also allowing us to get into the soil early in the spring when potatoes need to be planted. And tomatoes are planted every other bed on our farm. And so we put straw mulch between each bed to protect the beds and, protect the tomato plants from splashes, from soil splashes, which can transmit diseases. But this also means that the beds between the tomatoes are getting, some protection and some food over that period of time when they're not being planted. Tarping is also another, non-living mulch technique that we use. And we mostly just use tarping either over the winter to protect beds that need to get planted in very early in the year, because it's not always possible to get in with the tractor in this early spring when there's the freeze thaw cycles or heavy rain, stuff like that. We also use tarping, as I mentioned, before planting, but what I'm talking about here specifically, and this came into play a lot last year when we had extremely dry conditions, is that if a bed is, we weren't really able to seed the buckwheat the way we usually are in the summer because we weren't getting any rain. So we weren't able to germinate cover crops. So I was using tarps a lot more heavily just to protect the soil before a crop was put in there so that we weren't, losing soil through, it blowing away when it was windy because the soil was just so incredibly dry this last season. For living mulches, we use clover, like I mentioned. And then we also just allow weeds and grasses to stay in place in certain situations. Our large paths, we just let them grow naturally with what's there and maintain them through mowing to prevent weed seeds. We also, if there's excessively rainy or dry conditions, I will let weeds remain more than I would in a year that's not excessively dry or rainy. We still never let the weeds go to seed, but if you remove everything from the soil, you're going to have issues with soil blowing away if it's very dry, with soil washing away if it's very rainy. So because weeds tend to be the most hardy of the plants out there, they're going to pretty much find a way to grow no matter the conditions. Sometimes they do become the best thing to rely on to help, protect that soil, because you can rely on them to grow, whereas, cover crops may not germinate. And then I had mentioned that we were talking a little bit more about tillage. So some farms are moving in the direction of no-till methods, but we still continue to rely on tillage. So the reason that people might not be tilling is because if you're overly tilling the soil, it's going to decrease the soil structure because it breaks up the aggregates into a fine powder, which is then going to have further negative repercussions on the soil and on water infiltration. It's going to decrease soil organic matter because it lets in a lot more oxygen, and it's going to cause microbes to just eat through everything a lot faster. And that can result in leaching or in nutrients being lost from your system. Benefits of tillage is that it does, using a tiller does a great job of preparing a nice seed bed for your next crop. It loosens soil from compaction. It's gonna also have a benefit of letting in air, is that it will make microbes more active and allow them to release nutrients for the plants that are going in, as long as you're, continuing to provide enough organic matter back to the soil. it increases biological activity, which can increase soil temperature, which is very helpful early in the year when the soil's cold and its stuff's gonna germinate better with warmer soil. So on our farm, we still do till, but we rely heavily on compost, green manure, and things like that to try to mitigate the effects of tilling. So that even if we are losing some soil structure and some soil organic matter through tilling, we're putting as much or even more back into the soil system through compost and green manures and, crop diversity. Our soil tests back this up, showing that we've increased soil organic matter on the farm over the years despite tilling. However, we do make an effort to use a rotary plow, which turns the soil without destroying the structure, as well as hand tools to prep beds whenever possible in order to further, mitigate the effects of tilling. And just to be clear, plowing and tilling are very different in how they stir up and interact with the soil. And so when I'm talking about using a tiller, that's going to have a different effect on the soil than plowing. And, that's a whole different can of worms. So why do all of these methods we've discussed help build soil organic matter? They help build the food web in the soil by feeding the microbes and increasing good microbes and providing a diverse diet to the microbes, which is going to help feed the crops and outcompete problematic pathogens. The methods we've talked about also will help to rejuvenate microbe populations by adding in fresh microbes, fresh compost, fresh food for the microbes. And they're also going to be a way to feed the microbes a diverse diet, not just a diet, but a diverse diet. So increasing the diversity of the microbes of the food source of the microbes is just going to attract different types of microbes so that you have good biodiversity within the soil, and that's going to provide better food and soil structure and soil health over the long term in your system. So this is the soft conclusion, and then if we have time, we can look at a couple of those websites I recommended. So in conclusion, I just want to reiterate the idea of feeding the soil, not the crop. In an organic farm system, it's not as simple as just putting fertilizer on the bed. It's essential to create a healthy ecosystem in the soil as well as above the soil. You will rely on the dead and living organic matter in the soil to feed your crops. That is your crop's food. That is your fertilizer, is this system under the soil that's made up of the 5% living microbes and insects that are going to break things down, and all of the dead and decomposing stuff that's going to build soil structure and provide food, not just for the microbes, but in the chain. It's going to then provide food for the crops as well. So let's see what time it is. Okay, I can very quickly recommend that you look at both of these sites. I have them pulled up. There's two methods if you want to find out your soil structure. There's the jar method, which will, over time, it will separate out the soil layers, and you can kind of see the composition of your soil. There's also what's called I called it the clump method, but they call it the ball test and the ribbon test, where you basically take the soil. If it doesn't clump together, then you have sand. If it does clump together, then you do this ribbon test to try to determine if you have sand or loam. And then, you can then move on to is it gritty, smooth, or sticky? And that's gonna kind of help you further understand what type of soil you have. There's a huge big map that you can follow as you do this to help you further figure out your soil. I don't, it's saying my screen's paused again, so I don't know if you can actually see what I'm seeing.
We are looking at water retention and absorption right now.
Okay, let us shoot. All right,
let me stop and then reshare.
Let's reshare. Here we go. All right. Okay, I think I've got it up now. Share. Okay, so now are you seeing this website?
Yes, now we're seeing a website.
I'm sorry about that. Okay, so this is the flow chart I was talking about. I'll just really quickly go through. You heard me talk about all of it, but there's the jar method, the ball test method, and then through that, here's the ribbon test and the grit test. And then here's what I was talking about, where you can go through these tests, and this flow chart kind of helps you break down what kind of soil you have. The link should be on, hopefully is within the slideshow, so that you can get to this website if you'd like to. And then this is the web soil survey website that I had mentioned, where you can actually go in, and you have to press on this start WSS button to get in there, but you can actually see, let's see if it'll still let me show you. So this is what I pulled up for our property, for a portion of our property, and it will actually allow you to see exactly what type of soil you have. So what we have is called Poplamento silt loam, with a 3 to 8% slope, and you can see, all different aspects of your soil. So in the first 0 to 9 inches, it's silty loam. 9 to 58 inches is clay. 58 to 72 inches is, very channery, silty clay loam. So, and then it'll have depth to restrictive features. That's an important thing to pay attention to as well, because you can't farm on the top of a mountain where the depth to restrictive features, which would mean something that prevents root growth, like a rock. On the top of a mountain, it's going to be like 0 inches. So you want to have at least enough room that water can cycle through the soil and that plant roots can grow. But I would definitely recommend, whether you're looking for property or have your own property, is go on here and see what types of soil you have, and read through the description, because it will offer a lot of information, not just about the type of soil, but about how you can manage it for the best results. And that was all that I have for today.
Excellent. Thank you so much. That was a riveting presentation. Do you guys have any questions? That was a lot of information covered it all at once. And thank you again, Katie, for putting all that together. Does anyone have any questions about soils before we log off for the night?
Of course I do.
I think
This is Denise. You were talking about the inoculant stuff that you get from Johnny Seeds.
Yes.
How often do you apply that, or is it just a one-time thing, or?
So I apply it. Some people apply it with their cover crops if they're using a legume cover crop. I do not do that, and I've continued to find them on the roots of the cover crop, so I've continued to not do it. So the only time I apply it is with crop planting. So when I plant peas, I mix it into the pea seed. When I plant beans, I mix it into the bean seed. If there's any other legume that I plant that I'm forgetting, I mix it into the crop seed. And because of the crop rotation, that's then going to hit almost all areas of the farm over, several years. And that seems to have worked effectively on our system. But yeah, basically at planting of each leguminous crop is when I'm adding that in.
Okay, so only leguminous crop though.
Only leguminous crops,
Okay.
yes, because they're the only ones that those bacteria will be able to, be on the roots of. I'm not actually sure why, it's just those, but it is.
I think I've seen that in pictures before, those little pink balls that you were talking about. That's amazing. But anyway, thank you for answering
very
that.
cool. Yeah.
Now I want to go poke around and see if I can find some.
Yeah.
Thank you for your question, Denise. You always have such good ones and thoughtful questions. Do you have any
you.
more? Anybody else have any questions?
I do not.
All right, guys. Well, thank you. Our next class isn't going to be until April. I'm looking to pull that up real quick and tell you when it was. I had it up here earlier. But it will be, I believe, the second Tuesday. Let me pull that up. I don't want to tell you wrong, but you will receive a Zoom link right before the meeting, the same day of the meeting. just like we did today. How about April 9th, field-based organic production? So it'll be April 9th at 7 o'clock. We will be here ready to go over field-based organic crop production with Katie. And again, this is put on by the USDA through the Transition to Organic Partnership Program. We thank you for your time tonight. We look forward to seeing you in April. Thanks, guys. Good night.
Good night. Thanks, Katie.